In this tutorial video, we're going to focus on evaluating logarithms. So let's begin with something simple. What is the log of 9 to the base of 3? So what you want to do is that you just want to re-express this problem in such a way that the function and the base is going to be the same. So what would you multiply that will give you 9? What will you multiply by itself that will give you 9? Okay, 3 squared, or 3 times 3, turns out to be equals to 9. So definitely 9 can be re-expressed in an exponent form as 3 squared. So all I need to do, or all we need to do, is just to replace 9 with 3 squared. Okay, so this is simply equals to log of 3 squared to the base of 3. I believe by now you should have watched all the laws of logarithm videos I posted. If you haven't, you can click on the link that just pop out. Okay, so the 2 is allowed to come to the front of the logarithm in order to keep on having the general form of a logarithm expressions. So this simply equals to 2 log of 3 to the base of 3. Now we said the log of a certain value to the base of the same value simply equals to 1. So our final answer in this case is 2 times 1. And 2 times 1 is simply 2. And that's how to evaluate log of a certain value, okay, to a base of another value. Okay, so let's try to work out more examples. Feel free to pause the video and try to figure this out. What is the log of 16 to the base of 2? Try to check this out yourself. Remember, practice makes perfect. This simply equals to, what should we multiply that will give us 16? Now, here is a tip I'm going to share with you, and I would like you to keep in mind the tip. You just want to focus on the base associated with a logarithm. If the base is 4, then what you are to multiply will be a value of 4. If the base is 3, what you are to multiply will be a value of 3. If the base is 2, what you are to multiply will be a value of 2. Okay, because what you actually want to maintain is that you actually want to make sure that at the end you want to result in a situation whereby you end up having something like this, so as to turn it to 1 and have your final answer. I believe you get my point. Good. So what should we multiply that will give us 16? That will be a value of 2. 2 in 4 places turns out to be equals to 16. 2 times 2 times 2 will give us 16. So what this means in an exponent form is 2 to the power of 4. 2 to the power of 4. So definitely we can replace 16 with 2 to the power of 4. Okay? So this simply equals to log of is 2 to 2 to the power of 4. So just like what we did earlier, we are allowed to bring the 4 to the front of the logarithm value such that we will maintain in the general form of the logarithm expression. So this simply equals to 4 times 1, which is indeed equals to 4. So that is how to easily and mentally evaluate logarithm. Okay, so let's try to work out more examples. Okay, concerning different scenario. Hopefully you have written that. If you haven't, try to pause the video and try to check it out. Okay, so now what if you have problem like this? Log of base 3 of 1 over 27. What do you want to do in this case? What you want to do is that you actually want to be familiar with some basic rules and laws and indices. I've created a video with that. You can check out my playlist, and I'm going to leave the link in the description of this video, okay, for better and easier find out. There is a law known as a negative law in indices, or the inverse law. This simply says that if you have a value raised to the power of negative value, then the reciprocal of that same value raised to the power of what is being associated with will be your final answer. So a raised to the power of negative 2 is 1 over a raised to the power of 2. A raised to the negative 3 is 1 over a raised to the power of 3. You just need to keep that in mind. Okay, good. So that is exactly what you are going to be making use of. So let's re-express this expression as this: log of 27 raised to the power of negative 1 to a base of 3. So now remember, the base in this case is 3. So our goal is to find how many different ways can we actually multiply 3 with 3 such that we will end up resulting in 27, so as to end up having log of 3 to a base of 3, so that we can end up having 1. Okay, now notice that 3 in 3 places will be equals to 27. So definitely in an exponent form, 3 cubed is equals to 27. So therefore we can replace 27 with 3 cubed. Remember, 27 with 3 cubed, not 27 raised to the power of negative 1. So this simply equals to log of 3 cubed, okay, all raised to the power of negative 1 to a base of 3. So the next thing is to expand this bracket. So we have log of 3 times negative 1 is negative 3, all divided by all to the base of 3. Now we said we are allowed to bring the negative 3 to the front of the logarithm value in order to maintain the position. So negative 3 log of 3 to the base of 3. So log of 3 to the base of 3 is simply 1, and negative 3 times 1 is simply negative 3. So our final answer in this case is simply negative 3. Okay, good. So let's try to work out more examples in order for you to develop your idea in evaluating logarithm expressions. Hopefully you have written that. Now, what if you are having a very bulky base, but the function in that case is a very light function? What am I saying? How can we actually express log of 2 to a base of 32? What should that be equals to? Try to give this a try. Pause the video and figure it out. So just need to keep in mind, whenever the function or the variable or the value is raised to an exponent, you are allowed log of a to b raised to the power of x is equals to x log of a to b. But what if the case changes? What if instead of having b to b with an index, you are having a? How can we actually express that? What am I saying? What if we have something like this? Log of a to the power of x to b. In this case, 1 over, sorry, let me put it this way, excuse me. This will be equals to 1 over x log of a to b. Okay? So you just need to keep that in mind as well. So our goal is to end up having something like this: log of 2 to a base of 2. Remember, I told you that will be what will guide you to on what to make use of. Now you have the function, the variable, to be in its least term, in its lowest term 2. So your goal is to express 32 in such a way that it will be a value of 2 multiplying itself in some number of places. In how many different ways can we multiply 2 such that it will give us 32? And notice that 2 in 5 places will result in 32. So definitely in index form, 2 to the power of 5 is equals to 32. So just like before, let's replace 32 with 2 to the power of 5. So left over, we're going to be having something like this. This is indeed equals to log of 2 to the power of 5 of 2. Now remember, we are allowed to bring 5 to the front of the logarithm in order to maintain the position, the general form of the logarithm expression. But the 5 won't be coming to the front of the logarithm and be acting in place of a whole number, but a reciprocal. So this simply equals to 1 over 5 multiplied by log of 2 to the base of 2. And log of 2 to the base of 2 is 1. 1 over 5 times 1 is indeed equals to 1 over 5. And that is how to express a logarithm with a very bulky or concrete base, but a very light function or variable. Let's try to figure out more examples. What about this? So try to check this out. Okay, so this simply equals to log of 3 to the power of 3 to 3. So when it's coming to the front, we have 1 over 3 times log of 3 to the base of 3. Log of 3 to the base of 3 is simply 1. 1 over 3 times 1 is 1 over 3. So here is the final answer. So that's the last thing I will want you to know about evaluating a logarithm. What if we are having a value to be raising a logarithm expression? Is there any way in which we can evaluate that? So what am I saying? If you have something like this, 5 raised to the power of log of is 5 to 14, you just need to keep in mind, whenever the base of the exponent is equal or is the same to the base of the logarithm expression, just set the function to be your final answer. For this expression, 14 is your final answer. So here's an assignment for you. Find the value of 7 raised to the power of log of 7 to 28. And secondly, evaluate the log of 1 over 2 log 3 to the power of 27. So feel free to share your answer with me on the comment section below, and I will make a video on it as soon as possible. Thanks for watching. See you guys in the next video. If you haven't subscribed, make sure you do that now, and don't forget to give it a thumbs up. Thank you.